Okay, hello everyone, and welcome back. Y'all, today we're looking at normal distributions. We've kind of talked about them. They look like this. It's symmetric, so we talked about them being symmetric before, but in particular, we're going to look at normal distributions here for the next couple days. The objective is to understand where a data value lies in a normal distribution. Guys, today's essential question: how can we use a normal distribution to explain where data falls within a population, within a set of data? Y'all, a normal distribution, it shows data that randomly varies from the mean. Varies randomly from the mean. And it displays in the form of a bell-shaped curve. This is the famous bell-shaped curve like this, okay? Guys, normal distributions, the reason we talk about them is they occur all the time in the real world. And here, I'll show you a couple examples here. We did this with the two dice. Let me get myself out of the way here. We did this with the two dice. If it just rolled it automatically, you see when it's rolling and rolling? All right, remember, if we just got a small sample size, it didn't really show us a normal distribution. But let's let this thing roll for a while. We'll come back to it later. The other one we're going to start is this Gauntlet board, it's called. All right, I'm just going to get it started. Again, it's dropping balls one side or the other, and they fall down here. So go ahead and start it. It falls into one of these slots down here, 0 through 6. You might have seen this on The Price is Right or some game show. All right, we'll come back to it here. Guys, we say that data is normally distributed when the mean, the median, and the mode are right about the same. All right, it's symmetric about the center. 50% of the values, half the values are less than the mean, and half the values are greater than the mean, okay? Y'all, this particular percentage graph, you're going to need to kind of memorize it. And we're going to do it a bunch of times here today. We're going to draw this, I think, 6 times. Guys, 68% of the data in a normal distribution falls within one standard deviation of the mean. 34% on each side, below the mean and above the mean. All right, then this spot right here between 1 and 2 standard deviations is 13.5%. Always, if it's a normal distribution. The percentages stay the same. What varies is the standard deviation. All right, so as you can see here, you all, 95% of the data, if you added up these 4 percentages, 95% of the data falls within 2 standard deviations of the mean. All right, now outside here, we're just going to call this 2.5% on this side and 2.5% on this side. That's all the way out. All right, that's more than 2 standard deviations on both sides, okay? All right, that's an example here. I'll slide myself down a little bit. Guys, a data set with a mean of 75 and a standard deviation of 3.8. And they're saying it is normally distributed. So what value is 3 standard deviations above the mean? Well, how do we calculate that? Well, it's pretty easy, guys. You take the 75, which is the mean, and add 3.8 3 times. You get 86.4. All right, just think of a number line. I'm going to add 3 standard deviations to the original mean. Again, another example. A data set with a mean of 75 again and a standard deviation of 3.8. And again, it is normally distributed. What percent of data is between 68.4 and 82.6? All right, if you go ahead and calculate the standard deviations, again, 75, I add 38 to it twice, and I get to 82.6. I subtract 3.8 twice, and I get to 67.4. So 2 standard deviations above the mean and 2 standard deviations below the mean. All right, so between 82.6 and 67.4, 95% of the data falls between those two values. You might be able to see it right here. Again, 75 is the mean. So there's 1, 2 standard deviations below it, and 1, 2 standard deviations above it. So between these two numbers right here, 95% of the data is there. All right, guys, just to conclude, normal distributions, they're symmetric. The mean and the median are almost the same. Again, it measures the spread from the mean. And 95% of the data falls within 2 standard deviations from the mean. And 68% of the data falls within 1 standard deviation of the mean. Okay, that's it, y'all. Thanks for listening.